Welcome to the Claw Compare Deep Dive Report. This is your comprehensive audio summary comparing ZeroClaw and OpenClaw, the two most talked about open source AI agent frameworks of 2026. Let's start with the big picture. OpenClaw, originally launched as Claudebot in November 2025 by Austrian developer Peter Steinberger, has become the fastest growing open source AI project in history. With over 185,000 GitHub stars in just 3 months, it's earned endorsements from Cloudflare, DigitalOcean, and IBM. OpenClaw is a ready-to-use personal AI assistant built on Node.js that connects to messaging platforms you already use, including WhatsApp, Telegram, Discord, Slack, Signal, iMessage, and Microsoft Teams. Its mascot is Multi, the beloved space lobster. ZeroClaw, on the other hand, appeared in February 2026 and gained 3,400 stars in just 2 days. Built by students and members of the Harvard, MIT, and Sendai Club communities, ZeroClaw takes a fundamentally different approach. Written entirely in Rust, it positions itself not as an AI app, but as an agent runtime kernel. A system-level daemon that turns AI agents into infrastructure services. Now, let's talk performance. This is where ZeroClaw truly shines. ZeroClaw's binary is just 3.4 megabytes. OpenClaw's distribution is about 28 megabytes, plus it requires the Node.js runtime, which adds roughly 390 megabytes of overhead. In terms of memory, ZeroClaw uses less than 5 megabytes of RAM. OpenClaw uses over 1.5 gigabytes. That's a 304 times difference. On a 4 gigabyte server, you could run approximately 800 ZeroClaw instances versus only 2 OpenClaw instances. This fundamentally changes the economics of multi-tenant agent deployment. Cold start times are equally dramatic. On 0.8 GHz edge hardware, ZeroClaw starts in under 10 milliseconds. OpenClaw takes over 500 seconds. That's a 50,000 times speed difference. For deployment costs, ZeroClaw can run on any $10 single-board computer, like a Raspberry Pi. OpenClaw typically requires a Mac Mini at $599 or a cloud instance, leading to the viral multbook phenomenon where developers bought Mac Minis specifically to run OpenClaw 24/7. Let's examine architecture differences. OpenClaw uses a gateway-centric design. A local Node.js process acts as the control plane. Every message, skill invocation, and memory lookup passes through this gateway. It features a channel layer that normalizes messages from different platforms, an LLM provider abstraction layer, persistent memory storage, and the Agent Skills plus ClawHub ecosystem with over 100 pre-configured automation bundles. ZeroClaw takes a trait-based plugin approach. It defines 8 core Rust traits: provider, channel, tool, memory, tunnel, observability, runtime, and identity. These traits act as standardized contracts, like Lego connectors. You can swap OpenAI for Claude or DeepSeek by changing the provider. Replace Telegram with Discord via the channel trait. Choose Redis, SQLite, or PostgreSQL for memory. All without restarting the daemon. ZeroClaw's memory system deserves special attention. It's a full-stack search engine with 0 external dependencies. No Pinecone, no Elasticsearch, no LangChain. It uses SQLite with FTS5 virtual tables for keyword search with BM25 scoring, embeddings stored as blobs for vector similarity search, a custom hybrid merge function, and LRU caching. Now, for the critical topic of security. This is where OpenClaw and ZeroClaw diverge most dramatically. In January 2026, CVE 2026-25253 was disclosed with a CVSS score of 8.8. This critical cross-site WebSocket hijacking vulnerability in OpenClaw allows one-click remote code execution. Attackers can force the frontend to connect to a malicious WebSocket server and immediately steal the user's authentication token. The scale of exposure was alarming. Security researchers found over 42,000 OpenClaw instances exposed on the public internet. Cisco's AI security team discovered 341 malicious skills in the ClawHub registry performing data exfiltration and prompt injection without user awareness. ZeroClaw's security approach is fundamentally different. It follows a deny-by-default philosophy. The gateway binds to localhost only and refuses public binding without a tunnel. Authentication requires a 6-digit one-time pairing code. An empty allow list means deny all inbound messages. File system access is scoped to workspace only, with 14 system directories blocked and symlink escape detection. All of this is enabled by default, not opt-in. ZeroClaw also supports built-in tunnel integrations with Cloudflare, Tailscale, and Grok, plus randomized gateway ports to reduce scan exposure. Let's talk about features and integrations. OpenClaw supports 13+ messaging channels and has a massive skill ecosystem. Its companion apps include a macOS menu bar app, iOS and Android mobile apps, web chat with debug tools, and SSH remote control. The community is enormous, with an active Discord server and thousands of contributors. ZeroClaw supports 15+ channels, including some that OpenClaw lacks, such as IRC, LARC, DingTalk, QQ, and email. It has 70+ integrations and a growing TOML-based skill manifest system. While its community is smaller, it's growing rapidly. Both frameworks are model agnostic. OpenClaw supports Claude, GPT, DeepSeek, and local models. ZeroClaw takes this further with 28 built-in providers plus support for any OpenAI-compatible custom endpoint. Now, for the secret finding that developers need to know. ZeroClaw includes a migration command, ZeroClaw migrate OpenClaw. This isn't just a config converter. It reads OpenClaw's configuration files and memory stores, translating the entire operational state into ZeroClaw's trait-based architecture. ZeroClaw's identity trait natively supports OpenClaw's Markdown-based identity format. Your agent's personality, memories, conversation history, channel configurations, and skill mappings all transfer with zero data loss. Here's the key insight: ZeroClaw was architecturally designed as a drop-in replacement for OpenClaw. The trait system's 8 boundaries map 1-to-1 to OpenClaw's subsystems. The Harvard and MIT developers studied OpenClaw's architecture extensively before designing ZeroClaw's trait interfaces. This is a classic embrace and extend strategy. Make switching costs near zero, then win on performance. For organizations running OpenClaw on expensive Mac minis, the migration to ZeroClaw on $10 boards could save thousands in infrastructure costs literally overnight. Let's summarize with recommendations. Choose OpenClaw if you want the largest ecosystem, the most polished user experience, companion apps across platforms, and the biggest community for support. It's the consumer-ready option that just works out of the box. Choose ZeroClaw if you need edge deployment, multi-tenant agent hosting at scale, strict security defaults, operational tooling like diagnostics and service management, or if you're running on resource-constrained hardware. It's the infrastructure-grade option for teams that take operations seriously. Both projects represent exciting directions for open-source AI agents. OpenClaw proved that autonomous AI assistants can go viral and gain mainstream adoption. ZeroClaw proves that Rust can deliver military-grade efficiency and security for the same use cases at a fraction of the cost. This has been the Claw Compare Deep Dive Report. All charts, data tables, and interactive comparisons are available on the companion website. Thank you for listening.